the diagram shows the structures of a bromo compound that may be formed by the reactions of bromine with a hydrocarbon. Okay, so bromine with a hydrocarbon. So when you see these, you have to know that bromine with a hydrocarbon. The hydrocarbon here can be alkane and alkene in our AS syllabus. So that's why I'm going to break it down into two situations. So it can be bromine with alkane. It can be bromine with alkene. Okay, so bromine with alkane, of course, this is a free radical substitution. Bromine with alkene is electrophilic addition. Okay, now which row is correct? Which row is correct? So they give you either additions or substitutions. Okay, so additions belong to alkene, substitution belong to alkane. Okay, so again you see electrophilic addition. This one is a correct match. Okay, correct match. Nucleophilic addition, you can just straight away disqualify it. Disqualified because alkane and alkene do not go through nucleophilic addition. So nucleophilic addition is for other homologous series. So how about C? Nucleophilic substitution. This is not for alkane and alkene as well. So we can just straight away disqualify C. So we have only two choices left, which is A, electrophilic addition, and which is D, free radical substitution. So it comes back to our situation here. We need to decide whether it is alkane or alkene which form this product. Okay, which form this product. So how to decide? Let's say I start from alkene. Okay, I start from alkene. So alkene is the one with double bond, like this. So if additions happen, you have to know that the bromine here will go through heterolytic fissions where they will break down to Br positive, and one of the the Br positive that's formed will go to one of the carbon here, and the other one will be Br minus, the other bromine will be Br minus, then the other Br minus will come to the next carbon. Okay, so basically that is the mechanism part. We are not going to focus on that now. We just need to know what their form is. The double bond that we have just now is now single bond, and two bromine will stick to the carbon, the two carbons that are previously having double bonds. So our main focus here is the bromine will be side by side. Okay, the bromine will be side by side between two adjacent carbon, because originally the double bond must be in between two adjacent carbon, and when they form the product, the bromine must stay side by side. Okay, side by side. Okay, so side by side. Remember, this is alkene. Now when you look at the product here, these two bromine is not side by side. and hence we have to know that this product is not from alkene, because if it's from alkene, the bromines must be side by side, like what I mentioned here, side by side, because carbons that are originally having double bond must be the two adjacent carbons. So hence this is not side by side means not alkene. Not alkene means not electrophilic addition, and hence it is not A, and the answer is D, free radical substitution. So why free radical substitution? You may think about it in this way. It is free radical substitution because it happens randomly. It happens randomly. So imagine that bromines which form free radicals can go anywhere. So can go anywhere to substitute the hydrogens. Okay? To substitute the hydrogen. So that's why it goes anyway. So one will come here and another one go to that position. So free radical substitution is hence the answer, because free radical substitution happens randomly. The free radical Br dot will randomly attack any carbon. So that's why.